Welcome back. We are looking at a little bit of a review of how to solve polynomial equations analytically. And we'll deal with how do we solve the related inequalities analytically. So from the previous section, we did have a technique of if we were trying to solve the polynomial equation, the first thing we would try to understand for ourselves would be, can we factor? And if we can, that's what we do. So if I'm looking at part A, I'm seeing that I have 4 terms in my left-hand side or in my polynomial. And everything's set equal to 0. So I'm going to try to factor this by grouping. So I'll group the first 2 terms and then the last 2 terms. And I'll take the GCF out of each of the 2 groups. So in the first group, I believe I can pull out an x squared. And what would be left over would be x plus 7. In the second group, I see that a 9 is a common factor. And whether you take out a positive 9 or a negative 9, it's kind of up to you. You have to kind of try it and see which way works out better. But remember, the goal is to be able to get an x plus 7 in the factorization. So if we need positives in the factorization, or at least that binomial part, I'm going to pull out the negative 9. And whenever I pull that out, it's going to change the signs. So that's going to give me x, and then 9 goes into 63 7 times. So you can see factoring by grouping is serving us well. We're not quite done with the factorization though. Remember, you would pull out this common binomial factor, which is an x plus 7. And then you have your remaining x squared minus 9, still equal to 0. I do have a linear factor as x plus 7, and I notice that x squared minus 9, it can be factored further. That's a difference of squares coming back. So I'll rewrite, I still have x plus 7, and x squared minus 9 would be x plus 3, x minus 3. So still equaling 0. And then notice you have 3 linear factors now. Last thing is to find the corresponding roots or the solution, setting each factor equal to 0. And if you know a little bit of a shortcut, you can feel free to utilize it. We should be getting x equals negative 7, or x equals negative 3, or x equals positive 3. So you do have your solutions for part A. We have, I'll write them in order. I have negative 7, negative 3, and 3. So those are the roots of your polynomial, or the x-intercepts. Also known as, and I'm going to bring this to the front of your mind again, I don't know, but if you remember, we called these the boundary points that are later going to help us out with our 2 inequalities. So you probably guessed it. You probably see there's some sort of relationship between this section and 3.3. And I'm going to tell you it is. We're actually bringing back the sign analysis method. So for part B and part C, you just pick one of them. And what you're going to look at is going to be using the sign analysis method. And the good news, by solving part A, we already have our number line kind of broken up already. So I'm going to start with that. Just drawing a nice horizontal line. And I will graph my boundary points in relation to each other. So I do see I have negative 7 will be on the far left, negative 3 somewhere in between, and then positive 3. They don't have to be to scale. The idea is just to make sure you understand that the number line is being broken up into, how many regions do we have? Let's double check. That would be 1, oh, it's going to, give me a second there. It's going to color code this. That's 1 region, 2 regions, 3 regions, and 4 regions. So The idea between part B and part C is to understand what regions do we pick that satisfy the inequality. So I'm going to erase the highlighting because sometimes that causes some issues. And we're going to utilize the sign analysis method. Always keeping in mind that our boundary points usually are used in those interval notations somewhere along the way. In order to further subdivide, I'm going to take my factors. And so that would be seeing them on the side. I should have x plus 7 on the far left, x plus 3, and x minus 3. And I'll further subdivide my test regions into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different test signs that we have to test. Now, you probably had a lot of practice from section 3.3, but the idea is to pick a test point in each region and plug it into the factors on the left to get the sign of each region. So I'll start off at least kind of by showing you if I'm picking a test point, like for example, I'm testing x equals negative 10, I'll say. That comes in the region on the far left. If I do this, I'm just plugging it into negative 10 plus 7 and understanding that I'm getting a negative answer, and that's where I'm plotting the sign. Negative 10 plus 3, still getting a negative answer, I'm plotting that sign. And negative 10 minus 3, still getting a negative answer, and I'm plotting that sign. So you can continue to show the work if you need to, and sometimes it's helpful with some of the negative answers. So we'll go that route. Pick a next test point in between negative 7 and negative 3. We can maybe test x equals negative 4. And if we're plugging this in, negative 4 plus 7 is actually going to give us a positive answer. Negative 4 plus 3 is going to give us a negative answer. And negative 4 minus 3 is going to give us a negative answer. So that's why we're plotting this in the region. Moving along, I'll test out 0 in between negative 3. I love that. 0 plus 7, positive. 0 plus 3, also positive. 0 minus 3, negative. And you don't have to show the test work that I'm showing, but this is just really nice for purposes of lecture. So you can see where I'm getting these signs. Last region, we'll have a test point. We'll also test maybe x equals 4, x equals 5, whatever you like. So we have 5 plus 7, that's positive. 5 plus 3, also positive. And 5 minus 3, also positive. So now we have a bunch of signs. Keeping in mind the purpose behind this, these factors were originally multiplied. So we're going to take that same idea. Multiplying the factors is going to give us our polynomial. So multiplying negative times negative times negative will give us a further sign for the region. Positive times negative gives us a positive region. Positive times negative gives us a negative region. And positive times positive finally gives us a positive region. So we took a lot of time on this, but now this allows us to solve part B and part C quite nicely. So solutions. For part B, keep in mind, we are looking for less than or equal to 0. We are trying to understand where do we see a negative region. So let's kind of highlight that. I see that I have coming from negative infinity to negative 7. So negative infinity to negative 7. Understanding it was less than or equal to, so infinities always have parentheses. The negative 7 would have a bracket. And I'll be clear on that bracket. It'll be a little more exaggerative. The other negative region that I see, negative 3 to 3. So if we see a jump, we're going to use the union symbol. and then take -3 to +3. So that's our solution for part B. And our solution for part C, if we kind of look at the inequality compared, left-hand side compared to 0, greater than or equal to 0 would indicate we are looking for where do we have a positive region. So you can kind of see it's the opposite of what you chose for part B, but I'll remember this, so I'll kind of highlight that for you. We'd be looking at the solution to B, -7 to -3. We still have that greater than or equal to, so we have brackets. I missed that up there. See, sometimes when you look at part B and part C, you kind of catch your mistake. Did you guys catch that before me? If so, good for you. That part B should have brackets. Okay, going back to part C. Checking it out. We have another region that's also positive. We're going to go from 3 to infinity. So when we do have that jump, we use the union symbol. We have the 3 to positive infinity. And you finally have the solutions to the related inequalities.